Gaur on behalf of the India EU ICT Standards Project. And today we have a great fortune of discussing a very important and timely topic. So this is our knowledge series in partnership with TSDSI and ETSI. And this is the webinar number 17. And the webinar is titled as the value propositions of open standards in building a sustainable data economy for smart nations. The webinar is moderated by Professor Amruta Bharadwaj. Just a very brief introduction about Professor Bharadwaj. He is the chairman of the Robert Bosch Center for Cyber Physical Systems and a professor at the Department of Electronic Communication Engineering at Indian Institute of Science in Bangalore. And as some of you may know, that IISc is one of the oldest and also one of the reputed institutes in India. And among many other things, Professor Bharadwaj is leading a project which is called India Urban Data Exchange. Maybe Professor Bharadwaj can mention what they are doing in it. So what Professor Bharadwaj is doing, I think, is also linked with what our friends in Europe are doing. And we have a great fortune of having two speakers today, Omar Elumi and Mahdi Ben Alaya. And both of them, Omar and Mahdi, we have interacted in past. They have been to India, so they are also a bit familiar with India. So a warm welcome to all of you. And I hand over to Professor Bharadwaj. Just a housekeeping announcement before you start, Professor Bharadwaj, that we have these presentations, and once they finish, we will take up the questions. And the way we take up the questions, that the audience, they can type in the questions using the questions tab at any time during the webinar, but we will take up in the end. And then you can read out those questions and maybe answer them. So over to you, Professor Bharadwaj. Thank you very much for moderating this session.
Thank you, Sachin. It is my pleasure to moderate this particular session. And it's a very timely session because in India, smart cities has been one of the big marquee projects of our government. And in that context, we have been exploring how to kind of really ease the flow of data, enable sharing of data between various parties so that you can have new value-added applications created. And in that context, the work being done in European Union and especially ETSI is very interesting and relevant. And we are really fortunate to have two experts who have been very intimately involved with this work today to give a talk on two different aspects. The first talk will be given by Dr. Omar Elumi. He is a Bell Labs distinguished member of technical staff. Bell Labs is now Nokia. He leads the AI/OTI smart cities activities, and he was one of the leading members till recently. He served as technical plenary chair of 1M2M, and he's been in Nokia since 1999 and has held various positions, technical positions, research, system architecture, etc. And he has also co-authored books on M2M communications and IoT. He's also, of course, involved in a lot of research conferences and so on. So Dr. Omar will give an overview of 1M2M. Following that, Dr. Mahdi Ben Alaya is going to talk about newly created standard on NGSI. Dr. Ben Alaya obtained his PhD in systems architecture from University of Toulouse in France. And he has also been very intimately involved with 1M2M, and he has actually created a couple of open source softwares, both for 1M2M and now for NGSI-LD. And both are released as part of the Eclipse Foundation project. And he works very closely with ETSI. He's one of the ETSI experts involved in various activities of ETSI, including things like SAREF and so on, participating in many R&D projects and hackathons. So as Sachin said, we will first finish both the talks. First talk by Dr. Omar, followed by the talk by Dr. Mahdi. Please start as and when you think of your question, you type it in that panel on the right. And after both the talks are over, we'll take these questions. one by one. And the duration of the talks will probably be roughly about 45 minutes to an hour. So with that, I hand over to Dr. Omar Elum.
Thank you very much. Thank you for the opportunity to speak and for the invitation. This talk has been also prepared with Christophe Collinet, who is with the Smart City project manager in Bordeaux, and he's also the vice chair of the ETSI-LD Context Information Management Group, which produced the specification of NGSI-LD. Let me first start with this gentleman. This gentleman invented Ethernet, and he came up with an empirical law where the value of a network is proportional to the square of the number of its nodes, while the cost will follow a more or less linear function. This is great, and we think that IoT will follow the same path. In particular, if we manage to keep the cost structure linear as a function of the number of nodes. And this is going to be a big challenge, because on the southbound we have a large number of technologies and devices, and on the northbound we have, hopefully we can create the conditions for application proliferation. And that's the basis, I would say, for the data economy. If we manage to have any-to-any communication and master the total cost of ownership to keep the cost structure linear, this would be very important in terms of building a data economy based on IoT. Now, there are two approaches where you can integrate. So typically when you have two systems, you give me your specification, I give you my specification, and we write against the APIs of each other or against the interfaces of each other. But if the number of endpoints goes up, it means we will have the n-square problem in terms of integration, and that will, which means that point-to-point integration will not scale. This is extremely important for IoT because we expect a huge number of devices, networks, applications, platforms, and you expect all of this to be connected in order to move from the intranet of things to the Internet of Things. Second approach, you rely on platform providers, monocultures, and that could solve the problem, but it may come with a huge integration cost, system integration cost, and it will lock you into a particular provider. What we want to promote, especially as we try to build homegrown data economies, we try to promote an open standards-based approach. And that open standards-based approach goes from the networks and the devices, the communication protocols and technology, the platforms, all the way to the applications and the cloud applications. Now, what we try to do this by means of open standards. One M2M is being one of them. Of course, by sharing the data, it doesn't mean it's open launch and everything is open data. With the standards, we have the provisions to create access control policy, which govern really who can access which data at which context. Now, moving to the next slide. Diversity in IoT, a threat or an opportunity. It's so diverse. This is a slide that we prepared in the context of the Alliance for the Internet of Things Innovation, where we try to capture all the standards organizations and associations working on IoT. And you may think it's complex, but actually, one way of looking at this is you need to make a segmentation of this. And I will come back to that in a subsequent slide. What role for IoT standards? It's going to be very important because we want to make sure that this data economy will be inclusive, which means we provide a level playing field and equal opportunity for smaller players and larger players to establish themselves and make the most of the IoT data. So the values from our sides are combat fragmentation, lower the CapEx and OpEx, we call them the total cost of ownership, which means that by means of standardized protocols and APIs, you can simplify application development and deployments. And once you do this, you can start thinking about cross-vertical applications. This is in particular very, very important in smart cities, especially as we start seeing commercially viable cross-domain and cross-application use cases, and that's what will bring a lot of value. Time to market, extremely important, because you would have reduced development costs, reduced integration costs, and lifecycle management. And we argue that it's a foundation of a data economy because of this equal opportunity, because of avoiding lock-in, and because we are generating the data once and using the data multiple times. This is a slide from McKinsey, where they argue that 40% of economic impact requires interoperability between IoT systems. So they measure, for instance, in the context of smart cities, video analytics is very popular, but we have seen cases in the past where different applications dealing with video install their own cameras, and we have seen pictures where a lamppost, for instance, could host multiple cameras because there is no interoperability between the applications. Now, in order to navigate the different standards and open source and associations, it's very important to understand two aspects of IoT standards. One aspect is what we call the proximal IoT, which is about technologies in the IoT with focus on proximal functionality, like local network, body area network, proximal networks in general. They are mostly targeting smart homes, building. It could be also about the direct car-to-car communications. Connections between things are simplified. They use enablers such as discovery, advertisement, introspection, and onboarding to discover and connect and share data. Very often they need multicast techniques to implement the discovery. And a user is still in the center of this proximal paradigm because the devices need to be onboarded and connected to the network. Example of this, OCF, Zigbee, 802.15.4, OPC UA when it comes to the industrial space, and DDS. And there are also several proprietary or open home automation technologies. And then we make a second distinguish, which is the cloud counterpart of this proximal IoT, where and we call this the distal IoT, which is targeting the interconnection of those islands of proximal IoT to the cloud application and among themselves. The distal IoT is targeting larger scale deployments of M2M and IoT. They aim at hiding complexity of network, routing, access control, and sharing the data. So here you can start seeing that security becomes more important as opposed to the proximal IoT, where there is security is important, but there is less need for access control. Storing and sharing the data, which means that the data that's collected once can be used multiple times. The enablers are proven security, access control, selective communications, addressing. And in terms of example, we believe that one M2M is the only standard-based approach for distal IoT. There are multiple proprietary platforms out there. And of course, they come with a lot of tools and a lot of analytics. But the drawback is massive system integration needs and possible locking. So from this perspective, we believe that one M2M is unique in providing and addressing this need of distal IoT. I want to say a few words about smart cities, because that's a subject that we believe is extremely important, and actually smart cities is very structuring for IoT, and that's at least the way I see it. And we see an analogy with the internet. Originally, when the internet was first invented, the inventor had in mind the following applications: telnet, FTP, email, and eventually the internet became this. And the reason for which the internet was able to scale is that because it has been designed in an horizontal approach in mind. Smart city will be exactly in the same situations because we see it at the intersection of consumer IoT, where we have applications like home energy management, smart homes, enterprise IoT, where we have applications like asset tracking, fleet management, possibly building automation, and industrial IoT, where you have smart manufacturing, smart utilities, automation, process control. And smart cities is really at the intersection of all this because it could be about all of this. And this is where we see a lot of application proliferation similar to the internet. Now, this is a zoom on how we see the landscape for smart cities. It's very, very important if you want to understand the smart cities that you not only focus on standards, but also focus on associations. For instance, you have on the left-hand side associations which are dealing with smart cities, and they are not doing standards. They are mostly doing sharing best common practices, defining use cases, sharing experience, providing requirements to standards. On the right-hand side, you have standards, the connectivity, for instance, 3GPP. ITU is doing the KPIs, W3C is doing the web. For instance, LoRa is doing the connectivity. So we call them horizontal standards. But then there are also a set of vertical standards for specific needs like water management, street light management, metering. At the bottom, you have open source, bottom right. And this is extremely important because the kernel, while, for instance, when M2M will be facing the devices and facing the applications, when M2M doesn't specify how the data gets stored, how you implement horizontal scalability in the system, how you scale the internet in general. And we see out there a lot of commercial grade open source. This is extremely important because making sure that your open source is commercial grade is important because this is how you want to scale, provide resiliency, and make sure that you build the conditions for your system to manage big data sets. And then at the left bottom part is the different projects. In Europe, we have a lot of them. Synchronicity is very famous these days, but we also keep an eye on the India Smart City and India 100 Smart City projects. Their role is learning from experience and providing inputs to the open source, to the standards, and to the association work. I think I will skip this slide. This is about what we see as a priority for 2019 and 2020 in terms of standards and association work. We are dealing with data lakes, data monetization, open data portals, etc. I will probably zoom on one particular one, which is the open data portals. There is a website called dataportals.org, which lists 551 open data for smart city. And if you go and dig a little bit, you will see that a huge portion of them will offer file-based approach for open data in smart cities. And the other portion will offer API-based approach to consume open data for smart cities, but all those APIs are completely different, which means that an application developer developing his own application for CTA cannot use it as it is for CTB. And this is probably one aspect that we need to sort in the coming weeks or months. I want to speak about a vision for IoT evolution. So initially we started with vertical silos. This is something that belongs to the past, where you have a device, a network, and an application. We came across several of those deployments where you have a meshed RF network built for smart metering application, full stop. It cannot be used for other purposes. Then with IoT and IoT platforms, we start thinking about the making infrastructures and an horizontal approach we called IoT infrastructuralization, where you have open platforms, open standards, open source, and where we start reusing the same devices and the network. Then once we build these IoT platforms, we have to create the conditions for sharing the data, because eventually there are IoT is one source of data, but there are other sources of data, including open data. And the data lake is the approach where you consolidate your data into a big system. You try to build a single data model, harmonize the data models. Now, it may be connected to the IoT platforms, because an IoT platform could be also providing a data lake service as well. Then we start moving to analytics and making the best out of the data with dashboards and automation and predictive maintenance. And once you start doing this, you will figure out that the data generated internally within an enterprise, for instance, may not be enough to remain competitive. And what you do is you discover the need to enrich or train your algorithm with other data sets, and that leads you to participate in what we call the data marketplace and the data economy. The enablers for this could be the blockchains, governance, mirroring and discovery, abstract data formats. This is not the scope of this particular webinar, because I think this is the ultimate stage for the data economy. But we have developed this blog that can be seen afterwards in order to have a look. What will make this vision happen? I think I selected 4 enablers, which I will not be presenting in full, but they are horizontalization, so moving to horizontal approaches. Second is everything is becoming based on software. So things like configuring a network slice for automotive or for a smart city. This is in particular true in the context of 5G, where the city can help in order to build the smart city, which needs densification, for instance, by providing lampposts. But in exchange, they can get a slice for their particular use. And this is very powerful in terms of provisioning, and we speak about network as a service. We will speak as a network as a service in the future. Trend 3 is semantic interoperability. Madi will speak further about this. And trend 4 is, I think by now we sorted the connectivity issue. 3GPP, for instance, at the cellular networks are addressing the needs of long range, low power, and we have a lot of techniques for short range, low power, etc. So we have plenty to choose from, even though 5G provides a good opportunity because it solves many of the issues and many of the applicability statements. A few words about M2M. It's an association of more than 200 members. TSDSI in India is part of this. The standards get developed once and endorsed by all our partners in different geographies. It's a software framework. It's a software layer that sits between the applications. And when we speak about the application, it could be in the cloud, in the gateways, the edge cloud, or in the devices. This is the way we designed M2M. We designed the system to be very, very largely distributed, which means that any compute, which could be the device, can be running analytics and can be running applications. And it provides functions that M2M and IoT applications across different industry segments commonly need. Things like data transport, security, data collection, remote software upgrades. We see it like an Android for the Internet of Things, but it sits both on the field devices, sensors, and in the servers. And it's a standard, which means it's not controlled by a single private company, and anyone can contribute and make it evolve. I think it's very important to ask the question why one M2M and why at this point in time, especially knowing that there are some standards in IoT that exist for so many years, for instance, SCADA systems. And the answer is really that the IoT vision will not materialize if we don't solve the interoperability issues across applications and between devices and networks, and create the conditions for application proliferation and data economy. The other answer is that it's the only standard-based approach for digital IoT, and that's extremely important for a homegrown data economy and owning the data strategy of countries. Why now? I think the timing is extremely good because with the advances in devices and networks, the conditions are ready for an outcome-based economy based on IoT, and we can address a much larger set of use cases. This is how the architecture looks like. So we model the physical world, the things that you see at the bottom, and we represent them in the digital world, which means that they get exposed to applications. This is about some of the common service functions, which are the functionality of one M2M. You will find things like registration, discovery, security, group management, interworking, semantics. And this is providing a Gartner, which is a market research company, about one M2M. They see the business impact is that one M2M is providing mass market economies of scale through faster time to market for products and services. And you see here one M2M is here, and this is from 2018, but we are close to reaching the plateau of productivity, and we are seeing a lot of deployments. For instance, recently Dutch Telecom announced one M2M deployments with NB-IoT in 11 countries in Europe. And this is how they classify one M2M. So this is also from Gartner, and this is how they classify one M2M in terms of importance. So its importance is very, very high, and its mainstream to adoption or mainstream adoption is foreseen in the 2 to 5 years time scale. Even though this is from 2018 and the adoption is already happening big time in several geographies. Applying one M2M in the context of smart cities. This is based on a lot of discussions we are having with smart cities in different contexts. So it's clear that the horizontal approach is making its way in smart cities because of application proliferation, but cities are asking that we protect the installed base and the leverage the vertical deployments and the silos. Cities ask for a participatory and innovative approach using APIs and providing access to open data. Security and device management are becoming extremely important, and we see them going hand in hand. So based on this, starting from what you see on the bottom right, the legacy deployments, I would say, if you manage to build adapters on the northbound of the applications of those deployments to what we call a smart city front end based on one M2M. So this is the one M2M deployment, which is in the data center. It faces the gateways and the devices at the field domain. And its design is helps in scaling the number of connection, the number of security connections. It's doing device management. But once the data is collected by means of one M2M, it can first be shared directly with the city application and the dashboards using the one M2M APIs. But it can be shared also in the smart city backend, which is the big data part of the smart city. And here we start dealing with historical data, maybe over years of data. You can use brokers such as Kafka or Mosquito. And so from left to right, we are dealing with short-term data. And when we go to the right, we are dealing with long-term data, because you need to process the data. And in addition, you need to make that data available for the application developers in order to build mobile applications and help in this process of application proliferation. This is where we see a role for ISG SIM, for instance, which is solving the problem of exposing open data. But there are other value propositions as well. And again, when from left to right, the data gets more enriched because it gets processed by the city application and eventually injected back in the big data part of this picture in a rich format. The design principle for this is that the front end and the back end scale differently in this case. The front end is designed for massive, secure connections to devices. The role of standards in the front end is extremely important, because this is where the different parties exchange information, either from the networks or on the northbound to the applications. So standards are extremely important. But the backend you could offer a room for differentiations between the different players. And there are several choices in terms of commercial grade open source, Hadoop and Kafka and Mongo. The semantic engine is when you start to enrich data, and here Madi will speak about JSON and DL linked data. You should build value also for existing applications through the notion of adapters or connectors. And finally, as you can see in the previous slide, there is an interface to other platforms, because it's not possible for an IoT platform to exist on its own. You have to eventually connect to a distribution system operator, to an energy provider, to water management, which may not be owned by the cities. So it's very important that we connect the IoT platforms, and that's the basis for a nation and the foundation for a smart nation and data economy. I think I'm doing well on time here, and I want to hand over to Madi for his part. Sachin, can you make Madi presenter?
Okay, Madi, you are a presenter now. Thank you much.
Thank you.
Hello, everyone. Can you see my screen?
Yes, we can see your screen. Please go ahead.
Good. So thank you, everyone. Thank you, Sachin, and all the EU-India standardization team for this kind invitation. So from the beginning, I was convinced that to achieve the vision of interoperability and avoid vendor lock-in, there is a recipe composed by two ingredients. The first one is standard neutrality. For example, one M2M standard or NGSI-LD specifications. This is why, as a company, I was really involved in those organizations, and currently we are involved as vice chair of one M2M testing working group, and we're also a member of ETSI IGC, because there is the first ingredient, which is neutrality. The standards don't belong to anyone, and anyone could contribute. Second ingredient for me, which is also important, is open source. And we need open source to avoid really vendor lock-in. So as a customer, when you use a standardized solution, if you have a skilled and motivated team, you could by yourself keep building and extending the system, and you don't have to rely on any other actors on the market. So this will give you full autonomy to manage your systems. And of course, you could choose to use a commercial solutions, but you could switch when you want. So you really master the whole solutions and you are free. Now let's move to ETSI-GC. So regarding open source, we have Eclipse OM2M, which is open source implementation of the one M2M standard. So this is co-founded by Sensinov and CNRS. And currently we also published last week the open source implementation of ETSI-GC, which is called Djane, and I'm happy to share it with you. So maybe I will spend the first slide. Okay, to give the rationale behind NGSI-LD, why we need something new here, because Omar presented one M2M, so it's really promising solutions that enable data collection, device interworking, subscription notification, semantic, many things. So why we need something new? And I want to spend some time to explain this. So today there is a significant amount of collected data that is kept behind the firewalls of organizations, and this data never gets leveraged. It is benefits, but it's never used because there are many challenges that are not solved yet in terms of diverse data formats, security, authentications, as well as privacy issues. Take, for instance, the example of smart cities. As the technical level, there has been no agreed standard to expose open city data. By city data, I mean subset is IoT, of course, but there is more. There is some commercial data, proprietary data, data that is used to enrich the IoT data, the usage data, a lot of other data that is not yet considered by existing standard. It's very useful to application developers who in turn can process this data and provide value to citizens. Example, using their phones or web applications. I like the example provided by Omar regarding dataportals.org. So it lists more than 500 open data portals, and most of them use different APIs, preventing application portability. So this is really contrasting with plenty of data analytics and AI startups and researchers that are starving for high quality data that they can process, enrich, analyze, train their algorithm with, and so on. For me, as the market embraces the vision of IoT-enabled data marketplaces, the market will quickly run into the N-square integration problem. Yeah, the same problem we faced with IoT platforms, the problem will happen when dealing with data sharing and data integrations, because simply of the different formats that we have here when we want to go beyond IoT data. So typically, without an agreed data exchange format and related API, the whole idea of trading IoT data is doomed to fail. If data buyers and data sellers spend significant resources and wasting their times in converting those heterogeneous data formats. So this is, for me, the main challenges when we go beyond IoT and start working on a larger ecosystem like smart cities. I like the vision of Tim Berners-Lee. So this guy is the inventor of the web and linked data. And when we talk about high quality data, we need to define, at least we need to classify and organize this data. And this is one way to see the how we could classify the maturity of data. So the first star is when you take a PDF file or image and you put it on internet, you make it available. It's not bad, but it's very difficult to consume these data, especially by a software. The second level, 2-star maturity level, let's say, is when you put it in a at least a proprietary format, but like Excel files. So you could still read the file and use some tools to extract the data. 3-star data is when you use open format like CSV, JSON, or XML. The 4-star is when you start including context information on your file. So, for example, if you use the term vehicle in your file, you add a reference to explain what is the namespace. Why do you mean by vehicle? So here we have more semantic annotation on the file. So we use this through URI. And the last level of maturity, which is the 5-star, is when you link data with information about the context. So the vehicle could belong to persons, could be parked in a parking lot, and so on and so forth. Okay, and currently ETSI is trying to provide specifications for this 5-star deployment scheme. So ETSI is also known as NGSI-LD. So we could use ETSI, it's the working group, and currently the term which is widely used is NGSI linking data. And the LD here should not be linked data, but it is linking data, like JSON LD. So the LD is really linking data, so linking unstructured data, because this data is not linked yet. Okay, so I like to be very accurate in the terms. So NGSI linking data. So ETSI works on this through an ISG, and there is several work items so far. One related to the data model, one specification about the API, specification about the security, the use cases, and recently we have a new work item, which is the integration with M2M, which is currently will be done at ETSI SIM. So NGSI-LD is an information model, representation format, and open API. So a quick summary is how to expose in a lightweight way linked data. And today we have many nice way to really describe data, like ontologies using RDF and OWL. So ontologies are very efficient to do this, but this is not enough because we need to expose these informations. And of course, with ontologies, if you are an expert, you know how to use Sparkle. So it's really complex and requires some specific skills to manipulate RDF and ontologies. And in terms of performance, this will not work in some constrained environments. There are many problems and challenges that you need to solve if you want to work with pure RDF files. So here is the idea to use RDF as a basis and expose all the information we could find on an ontologies using JSON linking data as representations and a RESTful API. As simple as that. So basically, so far, NGSI-LD is an API that could expose any ontologies. And here, by exposing, I mean, you could retrieve the information by sending simple GET HTTP requests, but also you could use some advanced queries and filters to retrieve and traverse the graph, the same information that you could find in an ontologies. And also you could subscribe, you could put your filter and receive the data that you like. It could be very advanced, like I want the temperature value that is located in this place, from these sensors at this building, and so far and so on. You could really define very complex informations using the entity, the relationships, the properties that you could find in a normal ontologies, but in a very lightweight way. And this is what is powerful and what I like in NGSI-LD. So this picture shows how NGSI-LD addresses a larger scope. It goes beyond IoT to include data coming from open data portals, from commercial and proprietary data related to the usage, from inference and artificial intelligence, user applications, provenance. Now I will go a little bit in details to tell you how this is possible. So this is the data model of NGSI-LD. And it's not a partial view, it's really the current data model, which is very simple. And you will understand quickly that this data model could be mapped easily with any ontologies, because we have entity, we have property, we have value, and we have relationship. So basically, you could describe any graph, and any RDF file could be mapped to those resources. Okay, let's me present an example to be more concrete. So this is a graph of a vehicle located in parking. So in yellow we have a vehicle. Okay, the type is so the vehicle is A4567 type vehicle, and it has a property brand name Mercedes. And we have a relationship is parked, where it is parked in downtown 1, which is an off-street parking. And this parking has some property like available spot numbers, reliability, and every entity could have relationship, but also property could have relationship. So the available spot number is provided by a camera C1, which is type of camera, and relationship could have also a relationship. So is parked is provided by, and you have a person Bob. So you see, this is really a graph described using NGSI-LD, but you cannot distinguish. It could be also an RDF or OWL. So this is why it's very interesting, because we could have the same level of informations contained inside an ontology. We have the same informations exposed through a lightweight REST API. Let's go in deep really to show you how it works. I took the two JSON files. So just to give you more information about how things work. So on the left, we have the vehicle, the JSON of the vehicle. So the context informations, I have type vehicle, I put it in red, and here I have the context. So I can provide why I mean by vehicle. So I provide the context, the link, what we call the international resource identifier, or internationalized resource identifier. I have the same thing for the second resource on the right, the off-street parking. I have also the context. So the link. So this is a unique identifier. So I know exactly that I am talking of this particular type of resource, which is the off-street parking as defined by SIEM. Okay, this is the annotation part and enriching with context information. The green part is how we are linking data, and is parked links to an object, and this object is the parking. So the vehicle is located in this parking, and this is how it works. How json-LD and NGSI-LD works. Very simple. So NGSI-LD offers several deployments possibilities. The first one is centralized architectures. We have a central broker, and we have some consumer and some producers querying, retrieving, subscribing, receiving notifications from the broker. Very basic. The second approach is distributed architectures. So here, the data itself is not defined inside the broker. We have context sources distributed, and the broker is used only for distribution. So we have a context registries where the context sources could register themselves, make them available, and the context consumer could locate those context sources and ask for the information. And the distribution broker will distribute the data. Okay, and the last one is federated architectures. So here, when we want to do integration between different services, so we have many central broker or distribution broker available, and we have one upper federation broker and one upper context registry used to federate those different local deployments, let's say. So this is useful when we have already different brokers already deployed, so we have different services and we want to do cross domain data exchange, but also it could be useful for scaling the systems, scaling up and down, so we could replicate and handle the load. So in this slide, I provide the main features. So first of all, lightweight API, web friendly, okay, supports any ontologies, which means that by default NGSI-LD do not provide a new domain-specific data model and is not competing with the existing ones. No, it uses any ontologies or unstructured data and expose it through web-friendly API. Publish subscribe is very important because here we are dealing with REST API, but the REST API is extended with publish subscribe feature, so you could subscribe and receive asynchronous notifications based on filters. Security and privacy, of course, and temporal data, which means that the broker could have contain historical data, and you could also query those temporal data. Okay, the link with SAREF, I already introduced it a little bit this part. Since NGSI-LD is not tightly coupled or do not invent its own ontologies, it uses any ontologies. So SAREF and NGSI-LD are perfect match, because SAREF now is considered as a reference ontologies and is extended to cover several domains, including environment, building, energy, agricultures. So currently it is covering several domains. Even from the beginning, it was dedicated to smart appliances, but it's not the case so far. And we see how NGSI-LD and SAREF could work together, because, as I told you, NGSI-LD don't work without a data model. And if SAREF provide this common vocabulary for several domains, so really the vision of cross-domain will be possible and goes beyond IoT data to covers other type and other spheres of informations. Now it's time to introduce Djane and why you should love Djane. So it's open source implementation of NGSI-LD. We started this project recently, and we released the first version last week. Our idea is to build a sustainable data economy, support the European digital single market, and also promote it outside. Of course, the main goal is to really reduce the integration costs and avoid vendor lock-in. So we want Djane to be a reference implementation, and we are looking for contributors to help us achieve this vision. Why does it matter? For me, building a sustainable data economy needs standards for exchanging data. So a standard is good, but as I told you, for me there is two ingredients, and open source is the second ingredient. So a standard is not enough for proliferation of interoperable implementations and deployments. An open source is equally important to ensure time to market. And the much needed convergence to support and an IoT enabled data economy. So here you have the link of Djane. You could check the website. We have the source code on GitHub. You will find the Swagger API descriptions, which is very well documented. And you could start play with the Djane, and we will be more than happy if you could give us some feedback, and why not contribute and make with us Djane successful. And today we have initial deployments, and Djane is currently being deployed in the city of Bordeaux in France, Carouge in Switzerland, and Songnam in South Korea, in the context of Synchronicity Horizon 2020 project. And today we have the green light to deploy Djane in a large-scale pilot interconnect, which will start at the end of this year, which is focusing on smart buildings and smart cities. You could check the latest press release about Djane and Djane deployment in Bordeaux in this link. A few words about Bordeaux use case. So in Bordeaux, we focus mainly on electric vehicle use case. And currently, Djane is used as a main component for the data lake of Bordeaux. The use case we have here is to get data from electric vehicle charging stations and develop some applications to find the closest charging stations. This is a simple scenario, but also we want to correlate the information about the battery level and the weathers. So we are getting the data from weather stations and the batteries and see how the weathers impact the evolutions of the battery levels. And here we could see how we could use data from different sources. Sometimes from IoT devices, other coming from the outside, and we could mix these informations, describe them in a unified way, enrich these informations, and process them to generate insights. And this is the high-level architectures of the project. As you can see here, we have several cities. Some cities are using 1M2M, like Bordeaux in France and Semantic in South Korea. Some cities are using Fireware, Carouge in Switzerland, and Djane will be used to federate, unify the data, and develop applications, provide developer-friendly APIs for very rich types of data. So to summarize, I could say that Djane currently elegantly combines NGSI-LD API and any SAREF ontologies in a single open source implementation, and a seamless manner that is without the need to change the implementation when a new ontology is onboarded. This closes my talk, and now I will give the floor to Omar to present the last slide.
Very quickly, because we are running out of time. I think one M2M could be served as the basis of data economy, because it avoids lock-in to platform and cloud providers. And smart cities and communities are important pillar for smart nations. So this is extremely important that we make sure that smart cities use open standards, in particular one M2M. Multiple standards exist for connectivity, proximity network, etc. Therefore, one need to be very careful, because you need to compare apples and apples. But one M2M is the only standard that addresses cross-domain and cloud, the distal IoT data communications. The recent specification from ISG SIM can be used, in particular, beyond IoT data for data sharing and linked data and open data. And it could be complementary to one M2M from this perspective. Thank you very much for listening. We are very happy to get your questions.
Thank you, Omar and Mahdi, for a very nice, crisp presentation, giving a kind of overview for both 1M2M and the NGSI-LD. So we have a few questions which have come in. So the first question is essentially asking, please elaborate on the work being done towards harmonization with OGC. It appears in the slide, 2019 slide, I think vision for 2019 slide. So the questioner goes on to ask, does this mean that NGSI-LD will be extended to support resources that are OGC compliant?
Slide number, you say 29?
There is a slide which is called Vision for 2019.
I think
it might perhaps be
from Umar's slide.
Omar, perhaps. Yeah. I think this is part of the future work for this year and beyond.
Okay. I think you are talking about a slide where we see NGSI-LD, right? There is an architecture. This one, maybe. No?
I don't know which slide the questioner is referring to.
It's OGC is the Open Geospatial Consortium,
Yes,
right?
exactly. Yeah. So there is a slide where that OGC is there, and then I think there's some. It's talking about integrating. Yeah. Is there any plan to think of integrating OGC somehow, or?
The vision we have for OGC, if you go to slide 15, when we build this IoT platforms and the data marketplace, etc., one of the problems we see is that if you are starting to share the data, once the data is collected and processed, etc., if you are starting to put your data into a data marketplace, which means we are starting to trade IoT data, which means exchanging data and buying external data for the purpose of our own algorithm and intelligence, we came across the need that there is a need for standards in order to classify and say what the data is about. And that's where we see a role for OGC in this picture.
Okay.
Which is the
so
metadata.
You are looking at OGC as
the metadata to discover the data sets, etc. And it may or may not be about IoT. It could be much, much wider in scope as compared to IoT.
Okay. There is the second comment is from Dr. Mani Madhuswamy. I think it's basically saying that they, in their university, he hasn't mentioned the name of the university, but they plan to launch an MTech program in informatics and standards. So Professor Mani, I would request you to connect with Sachin Gaur and team from EU India organization, and also people from TSGSI and BIS and so on, and they could be very good resources for you. The third question is for NGSI-LD. So there is an example which has been given for NGSI-LD. So the questioner asks, can you please elaborate what is contained in the context for the vehicle? So this is that vehicle which is parked, the Mercedes vehicle. Does it contain a schema for what are the various properties of the entity type? Is there a context? Okay.
Exactly. It's a schema.
And is there a context for each entity type also?
Correct. So we have, I didn't put here, you see, I put some like 3 dots. We have some core contexts, which defines, for example, here, you see, I'm using type, I'm using ID, I'm using provided by, observed at. These are some keywords already defined in a NGSI-LD schema. And when I use an ontologies, so of course I will use the entity, the relationships, the properties from my ontology. So I need to reference those concepts using a context URI. So in general, it should contain a schema. Otherwise, it provides a unique or an international resource identifier. So there is no conflict or any ambiguity about the concept, for the concepts.
Okay. So in that context, I had one other question, which was, so as far as the property names go, you can have an IRI and you can create this link to, a separate file which has further taxonomy defined for each of these, or perhaps even an ontology. Yeah. What about the object IDs? So you have an object ID downtown one, which is linked to, in 2 different elements. Now, what if these are in 2 different context sources? So we are talking of the same vehicle, but there is information about that vehicle, maybe different aspects in different sources. Is there a plan to somehow create? How does one manage this? Kind of unique namespace for object instances.
So the context, the URI should be unique. So it's kind of international resource identifier, which means in this example, I know exactly what what I mean by vehicle. So it's the SIEM, the vehicle as defined by SIEM, and you could get the schema if it is available. So
right,
you have,
but what about the object? You are an NGSI-LD off-street parking dot.
so
how is that managed? Because objects are transient; they come and then they go. So is
this
there any,
is,
yeah, sorry, go ahead.
yeah. So you have the namespace and the value. So it could be a serial number or a simple string, like here down, town, or A4567, and these structures is defined by json LD and used by, of course, NGSI-LD. As you can see here, you have the URL NGSI-LD, the off-street parking, and then the real value of the ID.
Okay, great, thanks.
So this ensures the uniqueness of the ID.
Okay. Another question which goes as follows: for Indian Smart Cities Initiative, the questioner wants to kind of understand the difference and perhaps similarities between 1M2M and NGSI-LD. And the question is asking, do you recommend one or the other or both? I mean, what is the, because 1M2M in some sense is also has the capability of exchanging and exposing data as per some ontologies, right? So I think that's where there is some confusion between the positioning of 1M2M and NGSI-LD.
Okay, so let me explain this. So with 1M2M, you have the main features in 1M2M is interoperability, and through interworking proxy you could collect data from different sources. You could do device management, so you are close to the devices and you get those data. So these data, you cannot, let's suppose that you are getting data and put them inside content instances in this case. So the content instances are currently considered as black boxes where you have your informations, and you cannot query the informations based on domain specific attributes, not like here where all the attributes are exposed. So in 1M2M you could use semantic descriptor, but the semantic descriptor will contain RDF representation, so it could be done by 1M2M if you use semantic descriptors, but this means that you will embed RDF structures inside your resources. So 1M2M resources will just be used as a way to carry RDF file from one point to another, and then your applications need to parse the RDF file. What we do in NGSI-LD is this RDF file is transformed to a pure JSON file, and all these domain-specific data, like here parking, could be speed, could be then queried. So the NGSI-LD broker will offer data analytics features by default natively. So as a developers, you could ask for, I want the vehicle located in Bangalore with the speed less than 50 kilometers per hour, and you could add this very advanced filter, which will work on the domain-specific attribute of your entities. You see, the granularity here is we could work on the attribute level, which is very important for data analytics. So the main difference is currently in NGSI-LD will be more developer friendly and will save you time, and you will get better performance because this part is done by the NGSI-LD broker. With 1M2M, you still need to parse and work with the ontology file. So it's it helps and make it easy to work. So NGSI-LD for me is closer to the application, to the northbound side, and 1M2M is very efficient on the southbound side to interwork with IoT. And the second part is NGSI-LD go beyond to IoT and include all non-IoT data.
So there is a comment that from Lindsay Frost saying ISG CIM has several discussions with OGC, and they have a very extremely complex ecosystem and structure of specifications, and we look forward to working with them. And there is a follow-on question.
Just here, well, so Lindsay Frost is the Mr. Chairman of NGSI-LD, HIGC.
Right. So the question is, SAREF currently does not match NGSI-LD and it is bound to 1M2M. Is there any plan to do some adaptation or correction for NGSI-LD?
So as I said, NGSI-LD works with any ontologies, and currently, if you look at the NGSI-LD specifications, you will find the mapping of SAREF to NGSI-LD. And the mapping is really, how to say, fast forward, because NGSI-LD just describe entities, relationship, and properties in a RESTful and web-friendly way. So any ontology, any RDF file could be converted in a few seconds, automatically to NGSI-LD. So any ontologies, it could be mapped instantaneously to NGSI-LD.
I think okay. I would like to add to this. I think this subject will need further discussions because we are working in 1M2M on the applicability statements and how to integrate things. So there are still remaining some question marks. 1M2M is a standard and NGSI-LD is a specification. And as time goes on, we will be looking at ways to further clarify the applicability statement and how they fit with each other. There is some ongoing discussion on this.
Okay, there's a related question on, what is the state of adoption of 1M2M among commercial IoT device and sensor manufacturers?
There is a list of certified devices that can be available from TTA. The Global Certification Forum is a Tier 1 certification forum linked to the GSMA Association, announced a program for certification. So you can check from TTA and GCF the list of certified devices. 1M2M could be used in the device, the cloud, etc. We have seen a lot of deployments in Asia, Korea, and as I said, in Italy, Telecom Italia has a deployment. In Dutch Telecom, which is a Tier 1 operator in Europe, has announced, this is public information, availability of 1M2M in 11 countries. They also they are using this in conjunction with NB-IoT, but they have also smart city deployed. So it's making its way, and we see, as I said in the beginning, the plateau of productivity to kick off really 2019, 2020.
Okay, we can have lost the audio of Omar.
Hello? Hello?
Yes, we just lost you a little bit out there. The last sentence.
Well, I was speaking about the deployments. I mentioned the Telecom Italia. I mentioned the Dutch Telecom in 11 countries in conjunction with NB-IoT. I mentioned the UK One Transport. I mentioned Korea. I mentioned Japan. So it's being Bordeaux. So I mentioned there are several ongoing deployments. Some of them are very, very large scale. And actually, HPE has a deployment in India with LoRa. This is also public information. And we will see more announcements. I think we are reaching the plateau of productivity and the mainstream deployments in 2019, 2020.
Omar, when you see HPE with
thanks for that
LoRa,
clarification. There is actually there's a related question on IPR for related to 1M2M. Are there any IPR implications if vendors want to actually implement and offer 1M2M, which they need to be aware of? Yeah.
Well, the IPR regime of 1M2M is similar to 3GPP and ETSI, and it's compatible with DSI. It's fair, reasonable, and non-discriminatory.
Okay.
So it's the regular IPR regime. It's fair and reasonable. I'm not aware of IPR declared against 1M2M personally, but it's the common practice within the ICT industry, and all the ETSI standards, the Korea standards, the Japan standards obey to the same IPR regime.
Okay. So there is a question on NGSI. The question is related to the query language, which is built using ABNF grammar. And the questioner wants to understand the reason for adopting a complex format like this. When you know, I guess this is a developer, and he's asking, you know, it makes life a little complicated for the developer to understand this complex format.
I understand the questions, and personally, I don't like it as well. But you know, when you deal with the standards, you need consensus. And when I joined ETSI, the format was already defined and adopted. So we decided to implement it in our implementations. But since it is contribution driven, if we want to update it, we could join and contribute. So I had this discussion internally with my team, because yes, they asked exactly the same question. So maybe we will bring some contributions to make it more developer friendly. But you are very, very good comments. So I don't have the rationale behind this choice, because I wasn't there when it was defined.
Okay. So there is a question on you know, policies for data sharing between CIM and 1M2M. The question is, how will those be defined or set?
Very good question. There is a work item defined in IGSIM to define a kind of interworking or integration with 1M2M. This is a very early stage. I think it was defined like 2 weeks ago. And since I was in 1M2M technical plenary meeting in San Diego last week, we discussed. We received the request from ETSI. It's a kind of liaison to start and kick off the collaboration with 1M2M. So currently there are different views about how the two solutions could work together. And okay, this work is just started. And there is a document so far about this in the ETSI portal. But yeah, it's pretty empty, and we didn't yet complete it.
Okay. There is a question related to your federated and distributed architecture, essentially asking, how does the context registry provide discovery from various context sources in, you know, when you have this kind of a distributed and federated architecture? Are the API calls just passed onto the individual context sources? I mean, so what happens?
As far as, so we didn't yet implement the distributed and federated architectures. And I'm not sure about the maturity of the API, but for sure I think it will be through APIs. Okay. But currently, in terms, I think, in terms of specifications, this part is not yet finalized.
Okay.
So the
I think this
first
is
part,
probably
the
the final.
decentralized architecture, is the ones which is currently developed.
Okay. I think this is probably the last question which is there in the question board. So this is regarding the example you had for the NGSI-LD, and the question is they're asking is, what is the format for the schema? Is the schema also represented as a LD, or can some other specifications like JSON schema be used?
There are both. It could be JSON schema. It could be just it could be XSD, or just unique identifier. The unique identifiers helps defining the namespace and avoid ambiguity between concepts, but don't gives you information about the object itself.
Okay. 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 There's one more question. It just came in. If ETSI SIM is providing support for ontologies and semantics, is it required to have semantic CSF in one M2M implementation?
Say it again. Semantic CSF. You mean the common service function?
Yeah. So the question is, the question is, if CIM is already, the NGSI-LD is providing support for ontologies and semantics, then should the semantics related common service functions be implemented in one M2M? Do you need to have this?
I will let Omar. Do you want to take this question, Omar?
Okay, I want to take this. Absolutely, yes. It has to be. It's better that this is implemented because one M2M could function as a complete data platform and IoT platform. So, which means that the consumer of data from one M2M can trigger the metadata and can discover the metadata which is pertaining to IoT data stored in the one M2M. So it can function as completely autonomous system. The NGSI-LD comes into play when you want to, after the data collection and sharing with the backend applications, eventually for the purpose of historical data, you want to share with other, share between data sources, and that's where we see the role. But if you have semantically structured data, it makes data sharing even simpler. So yes, the answer is yes, it has to be implemented.
Yes.
Okay, I think we are kind of, sorry.
Yeah.
Madhi, you had.
Yeah, maybe one last thing. So today, if you want to use one M2M and semantic, so you could put RDF representation inside one M2M resources, and you could also use Sparkle over MCA interface to retrieve and query the data. You see here, you are manipulating semantic information using heavy tools like RDF and Sparkle. And this is feasible, and this is how it works so far with one M2M based ontology and SAREF extensions. I see NGSI-LD could complement one M2M by providing more web-friendly ways to get the same type of information through simple REST API. So it's kind of simplifications and make the interface appealing to developers.
Okay, I think we are kind of almost at the end of time for this particular webinar. I think it has been really very interactive, lots of questions, and we thank both Dr. Omar and Dr. Madhi for an excellent presentations, and also all the participants for logging in. We had about 50 or so people log in to attend this webinar. So with that, I hand it over back to the India EU ICT project team.
I think Sachin could be speaking to mute.
So, time and this session. Thank you for asking good questions. Thank you, Mahdi. Thank you, Umar, for sharing your time. And I hope this communication link stays between you and India, and you are able to exchange, contribute to each other. Have a good day.
Thank you.
Thank you. You are welcome.